So in this video, we will talk about conditional advertisement, how OSPF default route can be advertised based on a quad zero or BGP connection. So what I mean is that, let's say you have an ISP router and you are requesting from this ISP router a quad zero default route via BGP. And this is your WAN router. Now, when you have one single ISP connection or even two connections for redundancy, you can always request your ISP to send you a quad zero if you're not getting the full routing table on your WAN router. You would get the full routing table on your WAN router only when you need to make decisions and you have a lot of public facing servers that are for which the traffic is coming in. But nowadays everything is moving into the cloud, so the data centers / campuses really require a quad zero. Now, so ISP is sending you a quad zero through BGP, eBGP, and then your WAN router has a connection to your internal core router, and then you are running OSPF here. So essentially, the design is like you've got ISP1 and you've got ISP2. And then you've got these routers, WAN routers, that are connecting to your core via OSPF. And you want, this one is also sending eBGP quad zero. To your WAN router. So the intention here is that only when you see this route coming from your ISP would your OSPF router, WAN router or OSPF router, because this router is talking two protocols, BGP upwards and OSPF downwards. So your objective here is to make sure that you only advertise this quad zero downwards towards your network, data center, campus, what have you, when your connection is up. So you can do that by conditional OSPF advertisement. By a route map. So with this design, what I have is I've got a VOS1. I'm not going to do the entire design. VOS1 is your ISP. And you have a VOS2. That's your WAN router. And then you have your core router as VOS3, running OSPF here, and you're running eBGP here. Getting a default route through eBGP from your ISP, and you have OSPF running between your WAN router and your core router. Okay, so this is going to be your V1, your ISP router. Let's see if I can fit this in here. And you have your V2. This is going to be your WAN router. And this is going to be your core router, V3. So if you look at your core router, you're attracting all the traffic towards your core, and then core has a default to your WAN router. Whichever WAN router is advertising, you can do admin setting or do load balancing, doesn't matter. But right now your core router V3 has a default route coming from V2 that has a BGP route. This BGP route coming through this guy, which is your ISP. So show IP BGP summary. You're connected to this guy, right? And he's getting a default route from the ISP router. Very straightforward configuration here. Show interface. Ethernet connected on 1001. Show interface. Ethernet connected on 1002. These are the BGP peers, and then your OSPF is on 10.0.0.10, 10.0.0.2, and here on 10. .0.0.3. Okay. So now you have the BGP peer coming up, you've got the default route, and then let's just say the ISP has an outage. Disconnect the Ethernet here. The BGP route is going to disappear. This is down, it was up, it's down, and your BGP route is going to disappear as soon as the BGP timer expires. You can make the BGP timers aggressive with your ISP to make this quicker with BFD and all kind of fancy stuff. But as soon as this guy is not functional, you would have your default route in OSPF disappear as well. So let's expedite that. It should go away. Show IP BGP summary. Down 19 minutes. BGP, default BGP behavior is pretty slow. So you can expedite that by disconnecting this guy. And it would take care of that part. So now your BGP disappears because your BGP peering has gone. As soon as your quad 0 disappears from your BGP, your OSPF will disappear as well, right? Automatically. You bring up, let's do this one more time. Let's get this guy connected. And let's get this guy connected. And two-second up down, so it's up. Here comes your BGP, quad 0. Here comes your OSPF. Let's do this one more time. And you have a network failure on this router, or BGP failure, ISP failure, whatever you want to call it. Quad 0 disappears. OSPF route disappears. So bring it back up. BGP. BGP comes up. Quad 0 comes up on OSPF. So let's look at the OSPF show configuration, show protocol, BGP. BGP is straightforward, neighbor with the ASP, address family, unicast, remote AS, system AS. Very straightforward. Let's look at BGP, what do you call the OSPF. Here is where this is the network command pairing with your core router. Default information originate, not always, but check with the route map. So there's a route map with the check name. So let's look at the show route map policy here. This policy says rule 1 action permit match IP address access list 100. And if that matches, advertise, right? Action is 2, permit if you match access list 100. What does your access list look like? It says rule 1 action permit, destination any, source any, basically a default route. So if I were to show you show configuration commands, your OSPF is going to look like this. Set protocol OSPF default information originate route map check, and your policy for route map check is rule 1 action permit match IP address access list 1, and your policy here is a little down. Where did your policy go? Interface policy right here. Access list 1, action permit, destination any, source any. So that's your config right here that would do an conditional advertisement in VIOS. Obviously, there are much better feature sets in Juniper and Cisco where you can actually watch any of the internet routes instead of requesting Quad 0 and have OSPF advertise a Quad 0 into your network based on your connectivity, which is, IPSLA mechanism, which VIOS doesn't have it. But if you got something like a VIOS router as your edge router, you can always advertise a Quad 0 and OSPF based on the Quad 0 you're coming or receiving from your ISP. Hope this helps.